guys, I hope everyone had an amazing week. This week, someone asked me about arc length and how it works. So I'm just going to do a quick little tutorial on how arc length works. The thing about arc length that I like to keep in mind is that it's not about a formula. I mean, yes, we do have a formula, S equals theta r. You might not always remember that theta has to be in radians, or even the formula itself. So I'm going to show you how to derive arc length even if you don't remember the formula, and then we can talk about how the formula comes out of that concept. Enjoy! Here we have a circle with a little wedge cut out of it. We can see that the angle measure in the middle of the circle is theta. The radius here is labeled as r, and this little arc just from here to here, right here to right here, is s. There are certain things that we know about circles, right? We know that the circumference is 2 pi r, right? And we know that a circle, no matter what size circle we have, no matter what we do to it, always has 360 degrees. So we're going to use that information to find the length of s. Now the cool thing about circles is if we cut out a wedge in a circle, the degree measure, or the angle measure, if it's in radians, in the middle of the circle of that wedge is the same percent, or the same fraction of the whole 360 degrees as this little arc here is of the whole circumference, right? So we're just saying that the relationship between theta and 360 is the same as the relationship between s and the circumference. When we have two relationships that are equal to each other, we can set up a proportion. So we're going to say that theta relates to 360 degrees in the same way that s relates to the circumference, which is 2 pi r. So now that's all we really need to know in order to find arc length, okay? If we now cross multiply, we can cross multiply because we have a proportion with an equal sign. We can only cross multiply when we have an equal sign. We take 360 and multiply it by s. And we take 2 pi r and we multiply it by theta. And we're trying to find the arc length, which is s. So if we now divide both sides by 360, we're left with s equals 2 pi r theta over 360, right? But 2 and 360 here, we can do some reducing. We end up with s equals pi r theta over 180. That looks really complicated, right? But actually, if we think about the fact that we were just working in degrees, we can kind of go back to radians if we know them, and if we don't, that's okay. We can actually plug in our values right here and get an arc length if we're using degrees, because this is in degrees, the 180, and our theta is in degrees. So they are working together. So in a minute we're going to plug in actual values. But let's look at it for a second. If we want to think about it in radians, pi radians is the same as 180 degrees. So if our top values here, if our numerator is in radians, and we cancel it out with 180 degrees at the bottom, the pi and the 180 are kind of the same thing. So they would cancel each other out, and we would be left with s equals theta r. And that is the formula that you often see for arc length. And again, this only works as long as your theta right here, that's 2 arrows pointing at it. Here we go, we're going to make it one big arrow. That has to be in radians. If theta is in radians, this works. Otherwise, if you're in degrees, you can figure out this formula. You don't have to memorize it. All you have to do is understand that the angle in the middle relates to the total circle the same way as the arc relates to the total circle. And you can find this. So let's use some actual numbers. If we have a circle, and in the middle, let's say we have 30 degrees, and our radius is 2, and we want to find this arc. Now, there are 2 ways that we can do this. We can use our proportion, so we can say 30, that's our angle in the middle, relates to 360 in the same way as the little arc S relates to the circumference, which is 2 pi r. And then we cross multiply. We get 360s equals 30 times 2 is 60, 60 pi r. Oh, in this case, r equals 2, sorry. So times 2. So we get 120 pi equals 360s, divide by 360, divide by 360. We get s equals pi over 3. Now, we don't have to do all of that if we know how to work in radians and if we know our formula. And again, you don't have to know the formula. This way works just fine. But if you know the formula and you know, and you're comfortable with radians and you know that 30 is pi over 6 radians, you can say s equals theta r. So in this case, s equals pi over 6 radians times the radius, which is 2. You get s equals 2 pi over 6, and you get s equals pi over 3. Either way, you end up with the same answer, pi over 3, pi over 3. Your length of your arc is pi over 3, which, if we think about pi as an actual number, because we always have to remember that pi is just a number, it's a little bit more than 1. 3.14159 divided by 3 is going to be just a little bit more than 1. The length of this arc is a little over 1, and we are done. Thank you.